We have been talking about inflation, and now we're about to do a problem involving inflation. This example says, John wants to invest some money in his bank for 1 year. Currently, the bank is paying a rate of 4% compounded annually. Assume inflation is expected to be 2% per year. Identify I sub m, f, and I sub r, and repeat for inflation of 10% per year. Okay, so, oops, I'm going to do it over here. And remember the formula. First of all, let's identify. This 4%, oops, come on, what is it? This percent, because the bank is paying it, this is my market rate. This percentage right here, well, this one's pretty straightforward. Inflation is expected to be 2% per year. This is F. So what we're looking for then is I sub R. So we know that I sub R is equal to, sorry, that's an I. I sub M minus F over 1 plus F, which is equal to 0.04 minus 0.02 divided by 1.02, and it gives me 1.96%. So because it's a positive number, this is telling me that we're going to have more purchasing power. And I know this is an odd concept, but let's think about it this way. Well, first of all, it makes sense because it means that my bank is paying a rate higher than the rate at which inflation is growing. So I'm going to have more purchasing power. But I want to show you an example. Let's say that John wants to buy golf balls, I don't know, with his money for $5 each. Golf balls are probably not $5 each, but I don't know. It was the first thing that popped into my head. And let's say he has $1,000. So if he has $1,000 and wants to buy I don't know, whatever. I'm trying to think what else costs $5. Golf balls is fine. Golf balls for $5 each. Then at the beginning of the year, so at the beginning of the year, he's going to be able to buy, well, with his $1,000, $5 a piece, he's going to be able to buy 200 golf balls. Now, what happens at the end of the year? At the end of the year, sorry, taking a while. At the end of the year, well, that $1,000 is going to get some interest. So that's an F given P using the 4%, which is my bank rate, for 1 period over the $5, which are also going to grow, but they're going to grow on F given P at 2% rate, which is my inflation. Remember, things grow at the inflation rate and our money grows at the market rate for 1 period, and this is now 1040, and this is like 5.1. So now I can afford 203.9 golf balls. So you see what I mean by my purchasing power increased? I can now afford more golf balls with the same amount of money. And what is the percentage change? So if you do 203.9 minus 200, let's see, 203, I'm doing it in my calculator. I can do this, but I'm going to calculate the whole thing. Divided by 200, oh sorry, I forgot that part. Divided by 200 to find the percent change. This is equal to 0.0195, which is this. Slightly off, but that's because I rounded down here. So this is where that came from. Isn't that cool? All right, but we're not done. We have a part B to this problem. So let me go ahead and erase this. Okay, so now let's do it for inflation of 10% per year. So I sub r is equal to, in this case, it is going to be 4% or 0.04 minus 0.1 over 1.1, and this is equal to negative 0.055. So again, the golf club example, I know that at the beginning of the year I could get 200 golf balls. But at the end, let's see what happens. If I do the same calculation, 1000 F given P, because note that this is now larger. My inflation is growing faster than my money in the bank. So this is still 4% and 1. So this is still 1040. And my 5 is now growing much faster, F given P, with a rate of 10%. 1, and this is now 5.5, I think. Now I can only afford 189.1 balls. So that's less than 200. So you see, now my purchasing power decreased. And this is the effect of inflation. Great. All right, so now let's talk about going between actual dollars in year K that can be converted into real dollars as of any base period by the relationship below. And we talked about the fact that we were going to get this number, where we're going to multiply our actual dollars in a particular year times P given F using the F rate in this minus the basis year. So remember, this was 2015 and this was 1916, or an example we did before. Not that it matters, but not that it matters what years it is, it matters how you do this. So we have an example here that says Acme is considering expanding their remote packaging facility. After tax cash flows for their primary alternative are presented in the table below. Oh, sorry, I read that wrong. After tax cash flows for their primary alternative are presented in the table below. If the general price inflation rate, F, is estimated to be 3.3% per year during the 6-year analysis period, what is the real dollar after-tax cash flow that is equivalent to the actual dollar after-tax cash flow? The base time period is year 0, so B is 0, and that's another way to write it. You don't have to actually use years. So how are we going to solve this? What we need to do is we are going to go between this, and we're going to convert this to real dollars by taking it back a certain amount of years. So here I have how this works. You see, this was what I had before, and this is now. So I'm going to multiply each one of these times P given F, 3.3 for, and you're noticing that it's missing N. Well, the N here is this one, but it changes for every row. So that's why they didn't write it in. So 1 for this one, 2 for that one, 3 for that one, because these cash flows are happening further and you have to strip more inflation from them. And this is what my after-tax cash flow ends up being. So this is actually very easily done using a spreadsheet where you can just drag a formula down. But you see how this starts getting smaller, and you can just read this off a table if you ever come across a table that has 3.3. But you can easily calculate this, and you see how our after-tax cash flow decrease. So the internal rate of return when you have inflation is going to decrease, and that's why it's so important. We needed to make good, sound decisions, and sometimes if we have like a marginally better after-tax, like a marginally good after-tax cash flow, once we take inflation into account, it might not be worth it. We're going to stop right here and we'll continue on the next video.